On the second page, just to clarify, remember when we define our variables, we need to define them completely. And so the input axis is labeled as the altitude above the surface of the Earth. So if we have a positive or a practical significance of a positive value, it would be the altitude above the surface of the Earth. And then if we, in the output or the vertical axis, we have the temperature indicating degrees Celsius, but it is referenced at 0 degrees Celsius. So if it were a negative value, then the temperature is below 0 degrees Celsius or below freezing. Then when we go to write our statement, remember that we have an input value and an output value. So our statement always has to have an input part of our statement and an output part of our statement when we're talking about the meaning, or what does it represent, what is the meaning in the problem's context. So at an altitude of 120 kilometers above the surface of the Earth, the temperature is 50 degrees Celsius. So again, we have the value and then also the defined variable, the value, and also the defined variable as well. And then I wanted to just point out that every graph in this class will be worth 7 points. And so those 7 points come from of those 6 things, kind of like your window, and on the graphing calculator, and then 1 more point for the actual points that you're putting on there. So in this case, we would have to make sure that we had an appropriate scale here. We have to label this axis, and so in this particular case, we're talking about the depth below sea level and the temperature in degrees Celsius. So D, and then I think we used T. So our variables, the computer stops jumping on me, T, and then we have got to name the variable. So this was the depth below the sea level, or just maybe just depth below sea level. And then this is temperature in degrees Celsius. And then we had to have an appropriate scaling. And so if we look at our information, it's going from 0 to 200 along the horizontal axis. So I wouldn't count by ones. I probably don't want to count by 25s because there's so many little marks here. Maybe if we get we have to go all the way up to 200, so maybe if we count by 10s, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 20, 30, 40, 50, 60, 70, 80, 90, 200, and we know we're counting by 10s. Remember, this point is always 0, 0. And then we're going to go from 20 to 1800. Well, 20 to 600 is going to be very difficult to graph, so maybe looking at the 600 to 1800, maybe if we count by 100, so 100, 200, 300, 400, 500, 6, 7, 8, 9, here's 1,000, 11, 12, 13, 14, here's 1,500, 16, 17, 18, so there's 1,800, and we need to indicate here that we're counting by 100s. And so there are 6 points right here. 1 for the defined variable, the scale is 2, the variable is 3, same thing along the horizontal axis, 1, 2, 3, so there's 6 points there, and then your graph itself would only be 1 point. And then lastly, I just want to point out that there is a statement in the very last part of this problem, and it's talking about if we want to change the scaling. In other words, we don't need anything between 0 and 57 since our data actually starts at 58. So to better accommodate the data that's given, we can use these little hash marks, slash marks, to indicate there's a jump between 0 and 57, and then the next one we see is from 57 to 58. So we know we're actually scaling this by ones. And again here, we're going from 115 to 170, but we're only counting by 5, so we have to indicate that there's a break in the graph, because again, this point right here is always your 0, 0. And if you notice, the variable is stated, its meaning, and its scale. The variable is stated, defined, the letter is given, and then we have the appropriate scale.